Hello everyone. In this video we're going to talk about the experimental method and how we use experiments to prove different psychological principles. So the experimental method is actually using experiments to prove different psychological concepts. And when we do an experiment, it can actually help us determine cause and effect. When we do different types of studies that we'll talk about, we're going to talk about correlational studies and naturalistic observation and surveys and things like that. That type of research can lead to lots of information, but it doesn't tell us that one thing caused the other. It doesn't prove that one medication is better than another. So an experiment tells us, it actually proves that one thing is better than another or that one thing caused another. So experiments are the gold standard for psychological research, but there's lots of things that we can't study with an experiment. Experiments are pretty complex and difficult to design, and so we'll talk a little bit about how we do design that. But there's lots of questions in psychology that people want to have answered. Does video game violence lead to actual violence in society? And we're going to talk about that. Is our society more violent today than it has been in the past? And actually the answer to that second question is no. Our society is actually less violent than it was in the past. You know, we watch a lot of violent shows on TV, a lot of violent movies, a lot of violent video games, but actually as a society, less people die at the hand of others today than in the past, than ever in the past. You know, we haven't had world wars, we don't have Roman gladiators killing each other in front of us, we don't have hangings, although we still do executions as well, but our society is definitely less violent today than it has been in the past, and that's an interesting question to answer. But both of these are really more correlational studies. It would be pretty difficult to design an experiment around this. Experiments are really good to study medications and new treatments. But we could design an experiment to study video game violence in kids, let's say. So first of all, with an experimental design, we have to design an experiment. We've got to define our independent variable, that what we're studying, and how we're going to decide whether or not what we're studying worked. That's our dependent variable. And how are we going to measure that outcome? So for little kids, let's say we want to decide whether or not violent video games make a child more violent. Well, what we might want to do is get a aggression scale, and maybe have the child's teacher and the parents fill out. And first of all, probably no parent would sign up for this study, but that's besides the point. But let's say let's say we get a group of kids and parents that are willing to do this, and they're going to rate their child's aggression before they play these violent video games, and we're going to measure that. We'll have the teachers measure it and the family members measure their aggressive. So we're going to get kind of a baseline level of aggression. And then we're going to have them play GTA for the week. And we're going to measure their aggressive behavior during that week and have the family members and the teachers rate their aggression. And that's going to be the measure of the dependent variable. How aggressive is that child? Our independent variable is going to be the violent video games. And then we're also going to have what we call a control group. And that control group is going to be playing, say, Mario Kart. So we're going to assign, and it's really important that we pick the same game as well, right? Because, Fortnite might be real different than GTA versus Mario Kart versus Super Mario. So we want to make sure we have exactly the same game that these kids are playing. We also want to make sure the kids are all the same age. We want to figure out it's very complicated designing an accurate experiment. And we got to find a sample of kids, parents that are willing to do this, and schools that are willing to do this. So if we're going to, study a group of, say, 6-year-olds, we probably, although they probably can't, let's say 8-year-olds, we maybe go to a school and see if we can get the school to agree to it. We got to get the parents to agree to it. Teachers have to fill out rating scales for us. Families have to fill out the rating scales and also let the kid play the video game. We might actually want to have the child come in and play that video game in front of us so we can see that they're doing that. So really, complicated experimental design. So what we're going to do is we're going to go to a school. We're going to pick, I think, second or third graders, 8-year-olds, and we're going to say, let's pick 50 of them. And we're going to randomly pick those out of, say, 200 kids that they have at that particular school. And then we're going to randomly assign each group to either the experimental group that's going to play GTA or the control group that's going to play Mario Kart. And then at the end, we're going to compare those two groups, and that's how we're going to decide whether or not our experiment actually worked. So finding participants can be a challenge, and that's one reason why when we talk about multicultural psychology that we often use male college students to do our research in the past, because they were readily available and the assumption was everybody else would respond the same way. So now we know that that's not true. And what we really want to do is get a random sample, a sample that really represents all people, not just a certain subset of people. And so there's different ways that we can do that. We might go to maybe a McDonald's or something, although you can think about it, and I put mall shoppers on here if you're going to do a survey or something. You could go. But is that random? Is a mall shopper, nobody goes to the mall hardly anymore. So is the mall shopper a really good representation of the whole population? Probably not. If you're studying high school students, you could get a representative group of high school students. So you want to make sure you get students from different backgrounds, different academic levels. You may want to keep the same grade, same age. But you could, get a group of high school students. But now, if you're using high school students, can you apply that information to senior citizens? No. But you can apply it to other high school students. You can generalize that. So the goal of random sampling is just to find a group that represents the whole population. And so if you're going to you want to do something that, is the entire city of, say, Phoenix or something, could be difficult to get enough people and enough representation. So sometimes finding participants can be really difficult, and that's why a lot of times college students are used, because they're readily available. So experiments are great for studying new medications or treatment, and it's much simpler to design an experiment based on just studying a new treatment or a new medication. And in fact, that video game example is much tougher to do an experiment based on that. So the experimental group is the group that actually gets the treatment. So if it's a new medication, they get the medication. The control group is the group that we're going to compare it to the treatment group. So if we're studying a medication, the treatment group gets the real medication, the comparison group gets no medication or a fake medication. And if in the end of our experiment, we can say that the experimental group that got the medication did significantly better than the control group, then we proved that our medication is effective. And that's the benefit of an experiment. So in an experiment, we have both an independent variable and a dependent variable. So the independent variable is what the researcher is studying. So it's the treatment, it's the medication, it's violent video games. In the bystander apathy study, it's, what location, what city does that make a difference? The dependent variable is the outcome of the treatment with the independent variable. Did the medication work better than the placebo? Did the bystanders stop and help? Did kids become more violent when they played those violent video games? So experiments are difficult to design, and there are also potential problems that we have to plan for when we're looking at designing an experiment. And we're going to talk about these three: the placebo effect, confounding variables, and experimenter bias. So most of you probably know what a placebo is. It's a fake pill that looks exactly like the real pill, and it has absolutely no effect on the person. But sometimes when people think that they're getting a real pill, they actually do feel better. And that's what the placebo effect is, that the person signs up for this study for depression, a new medication, they're excited to be included in this study, and they're really hopeful that this particular medication is going to help them, and then they end up getting the placebo. So the placebo effect will show that the person does actually feel a little bit better, even though they're just getting a fake pill. But When we design an experiment, when we're looking at medications especially, that experimental group that's getting the medication has to do significantly better than the control group. So even though the placebo effect may make them feel a little bit better, that medication should do better than that placebo effect. And then we've really proven that that medication is effective. But the placebo effect absolutely occurs. Then there's also issues with experimenter bias. If you designed a new medication or a new treatment, you might be really invested in proving that your new treatment or your new medication is going to work. There are always researchers that want to prove that violent video games are bad. And so there's a bias there already to begin with. And so we have to be really careful to try to make sure to get that bias out of our study. And one of the ways we do that is what we call a double-blind study. And so that's where the researcher doesn't know who's getting the treatment, and the participant, the person participating in the study, doesn't know who's getting the real treatment or not. So the experimenter doesn't know who's getting the placebo. The participant doesn't know who's getting the placebo as well, and that prevents the bias from occurring. Sometimes they will do what we call single blind studies where the experimenter knows but the participant doesn't. But there is always potential for bias in different research. And then there's also confounding variables. The book uses the term confounding, so you want to remember that. They used to call it extraneous variables, and I kind of liked that because it's kind of an extra variable. It's a variable that could impact your study unintentionally. If we did that video game study with kids and instead of GTA, maybe we did Fortnite with some kids and GTA with some kids, that could impact the outcome of our study. Same thing if we used Super Mario versus Mario Kart. You got to be really careful. You want to make sure that if you did that study about video games, you use the exact same video game for each group, because if you changed it, it could change the outcome of your study. In the bystander apathy study, if they used different actors, if they used a woman versus a man, if they dressed somebody that looked like they were homeless versus somebody that was dressed in a business attire, would that impact whether or not somebody would stop and help? Yeah, it definitely could. What part of the city could that make a difference? So what we want to do is make sure that we have the exact same condition in every scenario, so that we're not, so that outside factors don't influence our study. If we're giving out a placebo and it looks different than the real pill, that could certainly allow the researcher to know who's getting the real pill and who's not, but also could give a clue to the patients as well. So there are always confounding variables that you have to plan for when you're doing an experiment, and that can be really challenging. This is kind of a silly experiment I'm using just to give you an example of an independent and dependent variable. So we're going to do a silly experiment about texting and driving. And of course, the control group is going to be the group that's just driving through these cones down here. And the experimental group is going to be the group that's actually texting and driving through these cones. And then we're going to measure, how well each person, how good their driving was. So the experimental group is going to be the group that's texting and driving. So what we're adding to the situation is texting to the driving. The control group is just going to be driving. And then how are we going to decide who's the better driver? Well, we're going to look at how many cones they hit. And that's a nice objective rating. We're not going to be saying, oh, they did better or this person did better, because that would be experimenter bias and it wouldn't necessarily be accurate. It would be much more subjective. So we're going to pick a representative sample. We're going to just pick college students and we're going to randomly assign them either to the control group or the experimental group. Can you see anything wrong with this study? Do you see any confounding variables that might be possible here? I wish we were in class so you could actually answer me. But what about age? Should we be really specific about age? Because college students could be any age. They're not necessarily, sometimes we make this assumption that college students are 18 or 20 or whatever, but that's not necessarily true. So we may want to pick a specific age. And then what about driving experience? If somebody's 18, does that mean they've been driving for 2 years? Not necessarily. So we don't want to compare somebody that just started driving to somebody that's been driving for 5 years. That would be a confounding variable. What about the amount of sleep or what they did the night before? Somebody comes in for your experiment and they're dragging themselves in. That's different than somebody that had a good night's sleep. That could affect the outcome of your study. And what about the weather? What if one day you set up your experiment, it's bright and sunny, and then another day you set it up and it's windy and rainy and cold? Absolutely could affect your study. So confounding variables are things that you have to plan for in an experiment, and they're one of the things that make it difficult to plan a good experiment because things can interfere and then you're stuck with it. So there are disadvantages and advantages to experimental research. First of all, it's expensive. It's difficult to design a good experiment and plan for all those confounding variables. And sometimes the results don't always generalize outside the laboratory. And there are lots of things that we can't really test with an experimental design as well. A lot of concepts in psychology that we can't test with an experimental design. But the benefits of experimental design is that it's scientifically accurate. It gives us data to support our results and prove our results, so we can be much more sure of our results. We have much more control over the variables, and it's great for the study of medication, new treatments, and really proving that particular treatments or medications are effective. So experiments are really a useful tool in psychology, but they're not always possible. It's not always possible to do an experiment. Like I said in the beginning, it's kind of the gold standard for research in psychology.